Okay, thank you very much, Hemant. Um, as you can see from the title of this slide, I'll be talking about uh, how to use variants with Adams real-time. For those who are not familiar with the concepts of variants in Adams car, the concept here is that vehicles, when they're engineered by OEMs, are not just single configurations. They actually have multiple configurations of those vehicles. And in order to manage the complexity of the various models that are required to simulate all those various configurations, we've added a concept called a variant to an Adams car model that allows you to manage some of that complexity a little bit more easily. So the basics of variants are, as I just alluded in some earlier releases of Adams. Each Adams car subsystem and assembly has always represented a single vehicle configuration. So here we can see an example of what I'll just generically call assembly one that uses, some set of subsystems, each of which are configured a particular way. Now we've always had the capability for expert template builders to use the concept of what we call group activity to control which modeling elements are active at any given time in a subsystem. And as a result, you can uh, do some reconfiguration of subsystems using group activity and get some flexibility in vehicle configuration. However, once that subsystem is reconfigured, if you wanted to save that specific configuration, you would have to create a new subsystem instance and then create a new assembly using that subsystem instance. And as a result, each assembly, um, as it's saved and reopened, represents, again, just a single configuration. And if you want to use different configurations, you have to switch around the group configuration, the group activity, or possibly replace an entire subsystem with a new subsystem if the template is different. In Adams 2017 and later versions, we introduced the capability to create what we call assembly variants and subsystem variants. The concept here being that a single assembly can now represent multiple configurations of a vehicle, which could contain potentially changes or differences at the subsystem level, or so entirely separate subsystems replaced, or just variations at the component level of a particular subsystem. So the bottom line is this allows a set of different configurations of a vehicle to be saved in one compact assembly that contains all the variants. So when we're talking about, uh, as I mentioned, there's two levels of variant. There's an assembly variant and a subsystem variant. So what can be different? What can be defined in an assembly variant? Essentially, at the level of the assembly, you have a few different things. You've got the assembly class, and by that I mean, for example, the default variant might be a full vehicle assembly, while you can also have a subsystem assembly saved in that same assembly. So previously, a full vehicle and a suspension assembly would have to be two completely different assemblies, but with assembly variants, they can be saved together because they are different classes, which is now allowed. If you have plugins that are used in a particular simulation, the plugins that are associated with a particular assembly can also be saved. Um, Obviously, an assembly is made up of a collection of subsystems. So all the subsystems that are associated with both the default and any variant uh, assemblies would be defined in that assembly variant. And the variants of the individual subsystems could also be included. So if you have a particular subsystem that varies at, say, the parameter level of a particular component, that could be saved as a subsystem variant and associated with a particular assembly. So you can see this gets a tiny bit complicated, but once you see it in operation, it's fairly straightforward. The concept of a test rig is something that is important to using Adams car. And you have the option of saving a particular test rig when in assembly. Examples of test rigs would be the standard driver interface, or SDI, or perhaps the SPMM, suspension parameter measurement machine. And there are others, but the point is you have the option of saving a specific test rig with a particular assembly configuration or not. And the reason I say or not is because we also implemented something called on-demand test rigs around the same time that we implemented uh, variants, so that actually if the test rig is not stored with a particular assembly, it will be pulled in on demand based on the type of event that you are simulating in the current versions of Adams car. Finally, solver settings, if they are specified, can be saved with an assembly. Now, at the assembly variant level, things like hardpoints, parameter variables, general part definitions, switch parts, flex bodies, uh, FE parts, the section of those FE parts, nonlinear rods, the definition of anti-roll bars, any user-defined elements or UDEs such as springs, bushings, stampers, bump stops, etc., are part of the subsystems and can vary between subsystem variants, as can gears, general parameters, the spline definitions, and any general variables that are used to define a subsystem. So this is obviously the nitty-gritty of the design of the subsystem and the settings of the components in that subsystem. So as Eric pointed out in his presentation, the types of modifications that you're likely to make when you're converting a detailed Adams car model to a reduced order model include things like simplifying the suspension, possibly replacing full 60 OF bushings with simpler or alternative connections or arrangements. You might go so far as to turn off the bushings that are connecting various points and replace them with simple kinematic joints. You might, you will more than likely simplify your anti-roll bars, simplify your leaf springs, simplify your tire use modes, and switch to high performance options in your tires. We make it very simple to eliminate switch parts, eliminate interface parts, and finally, at least for the testing, you're going to set the solver settings to a fixed step integrator and set the H ratio. Obviously, those things are controlled in the real-time environment when you're actually exporting the FMU. Obvious, well, the integrator type will be set in Adams and then exported as is the H ratio, but these solver settings are controlled by the user. You're obviously the flex bodies add a lot of complexity, and you are likely to want to replace your flex bodies with rigid bodies or a simplified flex body. And again, these are all the different types of changes that would typically be made. And it's worth pointing out that when you use the kinematic mode, you may be removing compliances that are actually important for getting the proper behavior in some applications. So this can be seen as a little heavy-handed. It might be, you want to be judicious about using this option. So to make it clear what we're talking about in terms of real time, let's just take a quick look at an example. So if we look at our pickup truck rear-wheel drive assembly, which is a model that is available in the ACAR concept database. Database is actually loaded by default when you install Adams car. You can see that when you go to open an assembly, you'll see the ACAR concept database, and in the list of assemblies, you'll see this pickup truck rear-wheel drive assembly, which looks like this. In my case, what I've done is simply to uh, take that standard model, generate a simplified anti-roll bar. So you can see here, this has been reduced to two rigid parts with a single torsional spring between them, eliminating the individual uh, beam elements that would normally be modeling an anti-roll bar. We can further use a tool that's available to simplify the tire property files. And what that will do is allow you to eliminate or simplify the use modes and also turn on the high performance options of the tire fairly quickly. If I switch the front and rear suspension into kinematic mode using the toggle kinematic mode switch, which is under adjust in the Adams car um, menus, then I further simplify the model. Finally, with those changes made, I have the ability to quickly save each individual subsystem as a new subsystem variant. So in this case, I've done that for the modified ARB, front tires, rear tires, front suspension, and rear suspension. So I create a set of new subsystem variants with those changes that were made to try to accomplish an improved real-time behavior. I then go in, set my solver settings so that I have chosen an HHT integrator. Fixed integrations are turned on, in this case with a default H ratio of 1. And you might make other changes, but this is just an example. And finally, if I go into save as in assemblies, I have the ability to select a new assembly variant and then save that as a new variant, which I could call, for example, real-time, the real-time variant. Finally, what I'll see is that I have not only this new real-time variant available, but I also still have the default variant, which has the model without any of those modifications available for other uses. So the point is now I have a single assembly called pickup truck rear wheel drive that has both the default and this variant called real-time 1. If we take a quick look at the Adams car environment, you can see I have that vehicle model loaded. And just to give you an idea, you'll be seeing this real-time 1 variant indicated here as a name after the 2 colons. You have the ability to switch between variants using this tool here. And I could simply show that you'll also see you have the ability to create and save events in the event browser. Here what I've done is just created a simple maintain event using this to demonstrate that the vehicle running with those changes still doesn't quite run at real time. The reason being that we haven't reduced the anti-roll bar down to a simpler version. This model actually still, after those reductions, has about 700 degrees of freedom. Oh, and we have some kind of an issue here that actually usually runs. So I apologize, that that was not supposed to happen. But in any case, the point is we've been able to reduce this vehicle down um, to fewer degrees of freedom. In this case, it's still over 700, so it would need further reduction in order to be able to run it real time. But we can save that as a variant and have it available to simply reload very quickly and use it in Adams car simulation.